Hey there, folks! Before we jump into today's topic, I want to give a big shout out to XPNSec. Thanks to his groundbreaking research on file extension spoofing, we've got some fascinating stuff to discuss today. Imagine a scenario where you receive a file that looks like a harmless PDF document. You might think, no big deal, it's just a PDF. But behind that innocent facade lies a sophisticated deception. We'll explore how attackers exploit a subtle vulnerability in macOS, a vulnerability Apple tried to fix but couldn't completely seal. Our mission today is to reveal the inner workings of this attack. We'll delve into the technical details from the tricks used to fool macOS to the steps taken to create a disguised application bundle. By the end of this video, you'll have a deeper understanding of macOS security and a newfound awareness of the threats that exist even in the seemingly safest environments. So fasten your seatbelts. It's time to unravel the mysteries of macOS phishing through file extension trickery. Before we dive into this phishing technique, we must understand a few basic macOS concepts such as app bundles, GateKeeper, and notarization. What is an app bundle? An app bundle is a single file with a .app extension that appears as a folder to users. It simplifies macOS app distribution and installation by allowing users to drag and drop it into the applications folder. It contains all the essential files and resources needed to run the macOS application, including the executable binary, libraries, and frameworks. The app bundle is equipped with an info.plist file containing crucial metadata about the application, such as its name, version, and supported macOS versions. On the right-hand side, we have an example layout of an app bundle, within which there is a contents directory which contains different directories and files, such as info.plist, package info, resources, and macOS directory, which contains the main executable, in this case, example. What is GateKeeper? GateKeeper acts as a security barrier, checking the digital signatures of applications before allowing them to run. It ensures that the software comes from trusted sources and hasn't been tampered with. By default, GateKeeper blocks the execution of unsigned applications, those without a verified digital signature from Apple or a registered developer. This prevents the running of potentially malicious or unverified software. When users attempt to open an app from an unidentified developer, GateKeeper displays a warning message. Users have the option to proceed, but it encourages caution and helps prevent unintentional execution of potentially harmful code. On the right-hand side, we have a GateKeeper example, which is blocking handbrake.app, which is from an unidentified developer, and prompts the user to ask them, "Are you sure you want to open it?" What is notarization? You could say notarization is like the seal of approval for macOS applications. It means Apple has checked the app for any shady stuff. Starting with macOS Catalina, notarization is a must for apps. It's Apple's way of saying this app is safe to hang out with. Notarized apps can sail through GateKeeper's security checks without raising any alarms. It's like the app has a VIP pass to the party, no questions asked. We have a notarization example. So when a user tries to open an app that hasn't been notarized yet by Apple, the system prompts them that this app cannot be opened because Apple cannot check it for malicious software. Now let's dive into file extension spoofing. What is file extension spoofing? In previous versions of macOS, users could name a file test.pdf.app and finder.app would automatically remove the .app extension, displaying the file as test.pdf to the user, as seen in the example on the right-hand side. Apple implemented a modification preventing registered file extensions from appearing before .app without exposing the true extension. For instance, if a file is named test.pdf.app, it will display as test.pdf.app instead of test.pdf, as seen on the example on the right-hand side. However, using an invalid extension like .enox would result in it being displayed as test.enox rather than test.enox.app, as seen in the example on the right-hand side. How can it be abused? By exploiting file extension spoofing, a technique that disguises the true file type, we can create a deceptively innocent-looking app bundle containing malware. By assigning a familiar icon such as .docx or .pdf, the malicious bundle masquerades as a harmless document or file. Once the victim executes what they believe to be a regular file, the app bundle triggers its payload, running the embedded malicious code on the victim's system. Seen previously, Apple had patched this vulnerability, but luckily, XPNSec discovered a bypass for this vulnerability patch. Let's proceed with reversing launch services. to discover the bypass. Let's begin by reversing finder.app. So we load finder.app into Hopper disassembler to obtain its disassembly. And after analyzing its disassembly, we find an interesting class named TUserDefault, within which we find show all extensions changed function being invoked from launch services. This function looks really interesting, so let's now analyze it in launch services. We load launch services from DLD share cache into Hopper disassembler to obtain its disassembly. Within this, we find a method named getPathExtensionRanges from path component being invoked in ls displayName constructor class. This seems to be responsible for obtaining the range of file extensions as seen by the arguments that are being passed to it. We also find a method named cleanSecondaryExtension, which seems to be responsible for cleaning the second extension, that is .docx in file.docx.app. Now let's analyze getPathExtensionRanges from path component method. Using the code provided by Adam Chester in his blog, which interacts with this method to obtain the file extension range. So if we were to pass a file name test.docx.app, it tells us the primary extension and the secondary extension. Based on our initial examination, we discovered that the presence of a secondary extension influences Finder's decision to display the .app extension. Let's now explore if we can manipulate this function to avoid recognizing the second extension by fuzzing characters, thus leading to Finder's omission of the .app extension. Using the code provided by Adam Chester in his blog, which fuzzes the second extension with different characters to check if any of them causes second extension to be not found. And based on the results, it looks like passing a space character followed by any other character will result in the second extension not being found. Next, we shall analyze cleanSecondaryExtension method to see how secondary extension is being handled or sanitized. We previously saw the implementation of this method in launch services, which is responsible for sanitizing second extension. Using Adam Chester's implementation of the above method and passing the extension pages containing space at the end, we see the sanitization it does. So as seen in the raw bytes, the space character is removed. The method seems to be sanitizing spaces, new line, and characters identified as illegal in Unicode specification. Let's add space followed by a character in second extension as discussed previously to see how this method sanitizes that string. And based on our results, we see that the above method does indeed bypass the sanitization, allowing us to spoof the extension. Finally, let's bypass the sanitization and get ourselves a working payload. Please note, if you were not able to understand the previous steps, these are not actually required to follow along or create yourself a payload. But if you want to understand it properly, I would highly recommend reading Adam Chester's blog on this vulnerability or this bypass. Let's begin with creating ourselves an application bundle that appears to be a PDF file. So the first step is renaming our malware.app directory to contain a space character followed by another character using the following commands. After that, a spoofed file name is now interpreted by finder.app as follows. It looks like an innocent PDF file. Now we've reached the good part, which is the demonstration of crafting our payload from scratch. Now before we begin, it's important you have these two things with you. First one being an Apple developer account, which costs around $99 a year. Second one being Xcode. It is essential to have an Apple developer account since this account will enable us to obtain a signing certificate from Apple, which we will use for the signing process. As a result, our application will be recognized and trusted, avoiding any gatekeeper prompts as previously discussed. We require Xcode for the development and signing of our macOS application bundle, which will be used to execute our intended code on the target host. Obtaining the signing certificate. Step 1 is go and log in on Apple Developer and head over to Certificates section. Step 2 is create a new certificate for app development. Step 3, use keychain to create a certificate request as shown in the screenshots. Step 4, use the certificate request to create a new certificate. Once you've obtained the certificate, download and import it into your keychain. Now we develop our application. So we first create an Xcode project in Objective-C and then we craft our malicious code into it. Unfortunately, no code will be shown here since we don't want to get in trouble with Apple. Oh, also note, you'll need to slip past notarization checks. That's your next challenge. Basically, notarization checks your app for security issues, so you'll have to be extra crafty to bypass it. It's like sneaking past the guardians of a treasure chest. The next step is to make our app look a lot more convincing to the victim. So we'll go and download PDF document icon from macosicons.com. After we've downloaded that, we'll convert the icons file to PNG using cloudconvert.com. After that, we'll update the icons of our app in Xcode using the images we downloaded previously. So the app icon looks like a PDF document. Step 5 is making sure the signing settings are configured, and after that, we archive our project. Step 6 is signing and notarizing our application. And please note, notarization process might take up to a few hours. Now that we're done with crafting our application, which is notarized and code signed with an Apple developer certificate, which makes it trustworthy and Gatekeeper won't raise any alerts to the victim. So the step 1 is using the file extension spoofing method so that our app looks like a PDF file type. Then we create an archive and deliver it to the victim. The victim downloads our archive using Safari in this example, which automatically unzips our archive and displays the following. It looks like a convincing PDF file. Once victim double clicks, our code is executed on their machine and it's game over from here. That's a wrap. We hope you've enjoyed this deep dive into the world of macOS security and file extension trickery. Your feedback means the world to us. Feel free to drop your thoughts in the comments on YouTube, Discord, or Twitter. Thanks for joining us, and remember to stay safe and savvy in the digital realm. Happy hacking!